3D printing sounds futuristic, automated, effortless, but in reality, it only works if you truly understand what's happening behind the scenes. Hello, I'm Dr. Baxmann, and in part 3 of our digital workflow series, we're finally talking about the heart of modern in-house production, 3D printing. Not the marketing version, but the real, practical side that determines whether it helps your practice or becomes a constant source of stress. One of the biggest advantages of 3D printing is simple. It works around the clock. While your team sleeps, printers can keep producing models. Scans collected during the day can be processed in the afternoon, printed overnight, and be ready the next morning. That alone changes workflows dramatically. But this advantage only exists if safety is taken seriously. Leaving printers running unattended without monitoring is negligent. Video surveillance, remote access, and emergency shutdown options are not optional. They are mandatory. Printers must be treated like clinical equipment, not toys. Another underestimated advantage is learning through observation. Just like patient photos help us evaluate treatment progress, recorded print sessions help identify failures, errors, and optimization potential. Printing can be boring to watch, but improvement comes from analysis, not shortcuts. Material choice is where things become truly important. Traditional plaster models are waste-heavy and difficult to dispose of. Filament printing, especially PLA, offers a healthier alternative. PLA is typically cornstarch-based, colorless, and far less harmful. However, disposal is still regulated. Compostable does not automatically mean legally compostable. Many EU standards are not recognized nationally, and organic waste bins are not a solution. You must understand local regulations before assuming environmental benefits. When it comes to printing methods, everything revolves around additive manufacturing. Filament printing, also known as FDM or PLA printing, works like a hot glue gun. The printer builds models layer by layer by extruding heated material. It's robust, affordable, and requires minimal post-processing. That alone makes it ideal for study models and daily workflows. Resin-based printing, including SLA and DLP, works differently. Liquid resin is cured with light. SLA uses a laser that traces each layer, while DLP projects an entire layer at once, similar to a TV screen. This makes DLP dramatically faster, especially for batch production. Printing time depends only on object height, not quantity. That's a massive advantage for high-volume labs. But resin printing comes at a price. Post-processing is unavoidable. Models must be washed in alcohol, cleaned manually, and cured with light. Resin fumes, skin contact, and waste disposal are serious concerns. Gloves, ventilation, masks, and hazardous waste protocols are mandatory. This is not something you casually set up in a small room without planning. PLA models, on the other hand, can often be used immediately if printed without supports. No washing, no curing, no chemicals. From a biological and occupational safety perspective, PLA is clearly superior. You could theoretically touch it freely without health risks, something you can never say about uncured resin. Cost differences are equally significant. Resin materials are roughly 4 times more expensive than PLA. Precision differences exist, but they are smaller than many assume. Surface finish is slightly finer with resin, but dimensional accuracy is often better with PLA. Some studies even show that resin models can deform over time after curing. Support structures add another layer of complexity. While sometimes unavoidable, they increase labor and post-processing. Avoiding them when possible saves time and frustration. Printing is never just press start and walk away. It requires learning, troubleshooting, and experience. 3D printing today is a bit like driving a classic car. Either you become a dedicated mechanic who understands every detail, or you rely on a highly competent support system that's immediately available when something fails. Printer downtime can paralyze workflows. When multiple printers stop at once, production collapses, and there's no quick return to plaster impressions. That's why starting smart matters. Either begin with an inexpensive printer to learn the basics, or skip the frustrating phase entirely by learning from experienced professionals who have already made every mistake for you. Both paths work, but ignoring the learning curve does not. 3D printing is not hype. It's a powerful tool when integrated correctly, but success comes from understanding materials, workflows, costs, safety, and limitations, not from buying the newest machine. If this helped you see 3D printing more clearly and realistically, make sure to subscribe, leave a review, and share it with colleagues. I'm Dr. Baxmann, and I'll see you in the next Lean Orthodontics episode.